and I don't have much to say. Okay, that should be streaming away now, I hope. It hasn't emailed me the link yet, but I'll post the link once it comes in. Okay, so CET466. I got through the content that I delivered last time I taught this course way faster, and the prime reason is because most of the lab time was out of class session time. You had to do a lot of the labs yourselves outside of the usual class time. So what I thought I'd do today is spend maybe an hour just reviewing the course and the final, and then we'll leave it there. I'm happy to stick around and help with any lab related questions. I'm happy to stick around and answer any other questions. But I have no new content today. You've got it all. It's all either in the videos or in the OneNote notebook or in the slides. So we should be good. So just a reminder, this is being recorded, and looks like the link, no, the link did not come in. I get so many, I don't know what it is, maybe it's the fact that a lot of stuff's happening online these days. I get so many emails saying, hey, have you've forgotten to buy your third cousin twice removed a Christmas present or whatever it is. But anyway, so they keep coming. So that's it, right? If you are planning on doing a project, I'm happy to help out with that. We'll go through things again. That's the iterated topic list. In fact, I don't think it's quite correct because I think I moved some of the projects around a bit more. I have had, I think, the first group finish all the labs. I just got I just had a look at the video just now. Let me see if I can bring up the video for lab 8, which is kind of nice to see. Oops, wrong class. Clicked a bit too quickly. Let me just bring that up quickly if I can find it. There it is. Oops. Okay, so here's the this isn't me doing it, this is somebody else. Right, the baseball counter, and it's got all the appropriate countings and the flashings and the new batter button. Right, so that was short but sweet. So, just put that back there. I've also had one person finish the game, which is actually better than I have. I haven't finished it yet, so I better do that. So that's good. So feel free to do that. What I haven't done yet is set up all of these things in Blackboard. I'll do that this morning once I've finished talking to you, and that way you can angle for which option is going to be the best for you, what I'll do is I'll put all the options in there, and then I'll also put a column that selects your highest percentage, so you can see which one I'm liable to use, and if there's an issue you can tell me about it. But that's what I'm going to be doing. Any questions about assessment or what we're going to be doing as far as getting a grade at the end of semester?
Hello, everybody.
Hello.
Good morning, good evening, wherever you are.
Could I briefly talk about what the test bench for Lab 8 should include? The main thing is to just check that the ball counter goes up to 3 and then resets, and the strike counter goes up to 2 and resets, and that each reset resets the other counter.
Welcome to
Oops, I've got
the meetup. Actually, ozone breaking the.
Sorry, that's I forgot to stop the video. It just kept going. Yeah, so that would be the main thing. You don't have to do a test bench if you do something like that video I just showed you, right? As far as I could tell, that video goes through all the possible options of counting up the balls and resetting, counting up the strikes and resetting, counting up both of them and resetting one of them, and then the new batter button as well. Okay, so provided there is some sort of demonstration that you've tested it, a test bench would be good. The test bench is hard to check the flashes that are there, right on, whereas the video makes it clear what's happening. Does that answer the question, Tommy? Okay, cool. I mean, you should be able to check the output going to that the right segments of the 7-segment displays are lit up from your counter, but it does make the test a little bit more complicated. But thankfully I'm a big fan of automated tests. Trouble is sometimes a manual test is just far faster to do. So the nice thing about an automated test is that you don't have to have somebody there to do it, but there can be a big upfront cost in doing those automated tests, in just putting them together and making sure that they are actually testing what you think they are. Okay, so let's have a quick look at the final. So I've released the final, and I believe most people have booked their sessions, and there's the email from YouTube telling me. So CET466 Final, let's see what that tells me. Yeah, I have 22 excuse me, 22 of the 27 people in the class have already booked your sessions, so please book them at your earliest convenience. And the funny thing is, I'm just searching on my my calendar, and it's going all the way back to December 11th, 2018, which is when the last time I gave a final in 466. So let's, I'll just grab the YouTube link and put it in the links. Okay, so funnily enough, the final is primarily about VHDL. So I'm giving you several either snippets or full-blown blocks of code to figure out what they're doing. And the first question, or the first listing, is this one, and the aim is for you to read through it and try and figure out what it's doing. And then the second question is about what does that generate statement do? Okay, so you should be able to figure that out. Second part, and this is again in the oral section, is asking pretty much the same thing as far as question 3 and question 1 are concerned. So here's another piece of code, and the question is, what is it doing? And you should be able to answer that. There's some, perhaps a little bit more information here than there was in listing 1. And there's a question about the generic block on lines 7, 8 and 9. What's that doing? And then questions 5, 6 and 7 are a little bit shorter, and they're asking specific things about, excuse me, they're asking specific things about parts of VHDL. You will have seen in in Model Sim these values on a static logic variable, but you probably haven't seen these other ones, and I suggest you have a read through and figure out what they do. Then question 6 is asking about the differences between a signal versus a variable. And then question 7 is asking about whether there are any constraints or what the constraints are on assignment of a signal when it's done within a process. And question 8 has another short, this one's a shorter listing, but again it's a full listing, and there's a problem with this this listing, and the question is, what do you do about it? What's the fix? And question 9 is another full question, a full listing, and the question is, what does it do? What sort of a device is it? And then questions 1 through 9 are all to be answered during the oral component of the exam, and then the last 2 questions are to be written or typed. And question 10 this is just gives you some examples of the sorts of things I'll ask, but questions, the listing 5 shows you the value of 4 signals, and listing 6 shows some examples of the sorts of expressions using those signals that I want you to evaluate and tell me what the values are. I will ask you during your particular exactly which expressions. They will be there will be 5 expressions, but they will be different from the examples shown.
Are we supposed to give you what the binary value is in decimal?
You should just give me
10?
for part.
Or for listing 5, it says rate the values of the required expression. Oh, they're both part of it. I just realized. Never mind.
Yes, so it usually will be what the binary value is, right? It might actually be more complicated. For example, in line 1 of listing 6, I think it'd be far more complicated to figure out what the decimal value of line 1 is than giving me what the binary value is. Right? Because that's going to basically concatenate A and not B, and C and D. A and B are both 4 bits. C and D are both 8 bits, so that's going to be a 24-bit value, and then you're going to have to convert that 24-bit value to decimal. It's okay to just give me the 24-bit value.
Cool.
Okay, and then question 11 you can do, you can prepare for, right? And I want you to write a template that tests all the operation of the device in the in listing 7. Okay, so you need to answer what the device is, and you need to, just to be clear, there's a what device is this question, but you also need to write the always process for the test bench. And I think it's not actually called Quartus Light anymore. I think it's called Quartus Prime. Maybe. Okay, so
when submitting this, do you want the Quartus file, or like will it just be fine to do it like on a notepad or something?
just all I'm interested in is the always process block. So just putting it into a Word file is perfectly okay. Just on that, it's not a big thing, but you will notice all of the listings that I've put in here use a fixed width font. I'm a big fan of always using a fixed width font when putting code into documents. Right? I'm fine with using proportional width fonts for the other text, like the questions are in the final. But when you put code in, specifically for question 11, I suggest you use either Consolus, which is a fixed width font that Microsoft came up with, or what's it, Courier New, which is also a standard fixed width font. The reason a fixed width font is better for code is because code tends to be tabbed out, and unfortunately for most fonts the size of each character varies. That's why they're proportional width, whereas with a fixed width font all of the characters are the same width. So things like tab alignments and everything just work out correctly with a fixed width font. Minor issue, but it does make reading in things like Word documents much easier. That's why things like Visual Studio Code or Eclipse or IntelliJ, those IDEs, they tend to use fixed width fonts, so things line up a little better. Okay, like I said, so far I've only had one. There's a question in the discussion. Sorry. Last two questions, Anthony. They will be a single submission. So the answers to both questions in a single Microsoft Word or PDF file, and upload that into Blackboard. And sorry?
No, sorry for interrupting.
That's okay. What's up, Javi?
I was just gonna ask after you finish, would you mind going over again, what are the questions being asked for the oral versus questions that are going to be asked for the submission?
Oh, okay. It's only the last two that are for submission. So these are oral, and you'll see it in the actual paper. I'll go get the paper shortly. This one's oral, and this one's written. And this one's written. Yeah, so 1 to 9 oral. That's correct, Anthony. So right, here's Blackboard, and there's the exam, and there's the oral exam, and there's the written exam. Okay, so that should be reasonably clear which one's which. Okay. Like I said, I've only had one group so far finish all 8 labs, so please get a wriggle on to complete the others. Yes, so the 120 time limit is we'll start the oral exam, and when we start it, I'll get you to start the timer, and that gives you your 2 hours from when we start the oral exam to when you can submit the your written answers, right? And question 11, you should be able to do that now, right? It's not as if you have to wait for the 2 hours. Question 10, you will have to I give you the numbers or the expressions that I'm asking you for. I'll give you 5 expressions. They'll be different from the ones in listing 6. The ones in listing 6 are just examples, but the ones I give you won't be any more complicated than the ones there. They'll be different, but they'll be of the same order of complexity. Basically, the format is exactly the same as what we did on the midterm. Obviously, different questions, different topic, but the process is exactly the same. Okay. Any other questions about the final? Anthony, you're okay with those answers? Okay. And there goes my dog for some reason. Oh, it's snowing. I just noticed that. That's interesting.
Yeah, it's really nice. It's just wet in my area of West Hartford.
Yeah.
It's not really sticking.
Yeah. Oh, I just noticed it then. I've had to play around with my lighting here, and I've got my blinds closed. I've just got an inch of window that I can see through. I can see all the big globby bits of snow coming down now. Okay, so let's go back to the beginning and give a quick run through, right? It's about 9:30 and I'm aiming to wrap it up. Probably might not make it before 10, but we'll see. Right, so the whole point of this course is to move you from the multi-sim, the discrete logic way of doing things, to how FPGAs work. Discrete logic is great. It's certainly great from a learning viewpoint, but oftentimes if you want to do more complicated circuits, logic circuits, things like PLAs, PALs, FPGAs are a better option. And in particular, FPGAs, there's two main strands. One lot are programmed using VHDL, and the other programming language is Verilog. I chose VHDL because that's what has been taught previously, and I haven't found much different from. It's about 50-50. Sometimes particular application areas use Verilog over VHDL, and sometimes the other way around, but neither language is particularly dominant. So I thought it was okay to stick with VHDL. The only slight thing that almost convinced me to switch to Verilog is that there seemed to be some more modern open source tools available for Verilog. But for what we need to do in this course, Quartus does, and ModelSim does everything we need to do, and they're both available for what we need freely. So I thought we'd just stick with VHDL. Right, so let's have a look through it. That's what it stands for, Very High Speed Integrated Circuit Hardware Description Language. You will see there are actually several other hardware description languages, HDLs, not just Verilog and VHDL. And part of the issue with VHDL is it's got a long background coming from the Department of Defense. What you'll find in a lot of Department of Defense stuff is they're very, very, very much sticklers for specification, for documentation. And that's why VHDL was developed in the first place. It wasn't initially developed for synthesis, for being able to generate code. It was intended to document how things are supposed to work as a specification rather than as an implementation. But if you can specify it, then you should be able to implement that specification. So that's why it moved the way it did. Right?
Is it still commonly used in Department of Defense? And if you say yes, I won't be surprised.
I'm not sure which is most used in DoD. I'm not sure which one is most used. I mean, you just about, if you put VHDL and Verilog into a Google, it gives you a whole list of comparisons and verses. I would suspect it's still quite used quite a lot. It is an IEEE standard, and again, the Defence Department tends to be very heavy on standards. Not that Verilog isn't, but I think the Defence Department funded a lot of the VHDL standards development, so they probably want to recoup their investment. Okay, so remember if you've ever used an Arduino or a Raspberry Pi or even some of the most microprocessors, they have general purpose I/O chips, right? And the nice thing about GPIO pins is to you can either use them as a receiver, as an input, or as a transmitter or an output. And the way you do that is by having something like this. Let's use purple for our pictures today, right? Something like this, where we can select whether we're or outputting right? And then the other piece is if you don't want to connect at all, then maybe you need this. This is effectively a switch. And it has a high impedance, or in VHDL or static logic terms, a Z value, right? Mostly static logic variables are 0 or 1 if you really want it, but they can also take on a high impedance value, particularly if they're connected to a bus and they're not transmitting or receiving on that bus at the time. Right, and there's the high Z values. And that's what I was saying about a bus, right? You've got lots of transmitters and or receivers connected to the bus, and you want to make sure that if you're not interested in what's happening on the bus, then things are turned off. But if you are interested, you know you're going in the right direction, either transmission or reception. And there's a bit more detail on, so in addition to ones and zeros, you want to be able to use other data types, and there are other data types available. You can use signed and unsigned values. You can use real and complex data types. Part of the reason you want to use some of these data types is you can use FPGAs to do things like signal processing, right? And what you'll find is a lot of the signal processing that you need to do for mobile phones and for high-end audio and that sort of stuff needs to be done really quickly, and it needs real and imaginary values or complex values to be able to be used. So that's why some of these additions to the VHDL standard were made, so that you can use FPGAs for higher end signal processing tasks.
Can I ask you a quick question about
That's what. What's up, Harvey?
when you're doing buses, is that when how are they able to interpret the different inputs as different inputs?
They're not.
If okay.
If you've got, oh sorry, different inputs. Well, all of the inputs on the same bus receive the same values, right? It's when you've got different outputs trying to output different things on the same bus that you have problems.
So like for example in your picture that you had above it said 101. How does the
Oops.
computer receive it and see the 101?
Okay, so in this case, you would only allow one of these values to be being output on the bus at a time. You could only allow this output being a 1, or this output being a 0, or this output being a 1. If you've got both of those on, then the value here is not determined. If you've got both of those on as an output, again it's undetermined. Both of those on, it'd be the same, but it's not quite the right thing to do to have the two outputs driving the bus at the same time.
Got it.
Okay.
Sorry about that.
That's okay. And Anthony, you asked about VHDL allowing encryption. Sure. You can implement a lot of the encryption algorithms, AES 128, 256, using, right? Encryption is just mixing up bits. It's a little bit of a simplification, but yeah, you can write VHDL that does encryption. In fact, that's an interesting question. I don't think there's anything that does it natively, right? So you still have to write the code to do it, but it's yeah, I mean there's a paper which is implementation of AES, right? So that's a little long-winded, but right, this is the sort of stuff you've got to do. But I don't believe VHDL will do encryption natively, but you can certainly implement standard encryption algorithms using it. Okay, that's on. So the parts we've been looking at are mostly in this region here, right? We're interested in thinking at a Boolean algebra sort of level or a state machine sort of level. And that's what the baseball counter, for example, is a state machine, effectively. It lets you transition between different states when you increase the ball count or the strike count or hit the new batter button. We haven't looked so much down here, and we could, right? Effectively the game MHRD is effectively putting together a CPU to run in a hardware description language. I wouldn't call it VHDL, but it's not too far off it. Okay, and then the other piece about VHDL is we've got, right, two different ways of writing it. We can draw it as a logic circuit, or we can write VHDL code. And that's the nice thing about if it's easier to understand what we're doing from just a diagrammatic logic circuit viewpoint, we can do it that way in Quartus. Or if it's easier to understand from a more of a coding approach, then we can do it that way. Right, and we sort of, let's right, so when we define a component in VHDL, there's two pieces to it. There's the interface, or the entity statement, and the behavior, or the architecture. Right, so that's the piece, right? The entity statement defines all the inputs and the outputs and says how the device we're devising interacts with the outside world. And then the architecture section says, okay, if we take these inputs and we mix them up and we shake them around, then we push out these outputs. And that's what it's aimed at doing, right? Right, so they're the sorts of things that you need to have in each entity. You need to have a name for it. You need to have a mode, whether it's an input, an output, a buffer, or an in-out type. We only focused on the in and out types. We didn't look at buffer or in-out. But you can think of that back-to-back transceiver right as the in-out type. So if you're connecting up to a bus, that's the sort of thing that's the mode you would use rather than input only or output only. And then you need to have a particular signal type. We could have used bit, but bit is a bit limiting. So we use the IEEE type std logic mostly, or std logic vector. And remember, VHDL as a language is strictly typed. And that means it's very, either you'll get an error if you try and mix and match types, or you'll get undefined behavior if you try and mix and match types. So you're better off making sure you know exactly what's happening with each of your types and how they interact between them. An example, most higher level languages, things like C++ or Java tend to be strictly typed, but other languages like to some extent Python and PHP don't tend to be as strictly typed. And particularly with PHP, you can get into all sorts of problems because of that, unless you're very careful. Okay, so there's the entity, right? And remember to watch the semicolons. It's always a bit of a problem. I know I always get tripped up, particularly with that last one, where there's no semicolon after signal type, but there is after the closed parentheses. Right, and there's an example for a simple adder. We've got 2 bit inputs and a single bit output. And here's another piece that sometimes we want to do. The keyword generic lets us specify constants, right? Here, this is a constant called bus width, and it will, whenever we see the word bus width, that'll be replaced with the integer value of 8 in this instance.
So are all variables signals, but not all signals are variables?
All variables? No, so there's a difference between a signal and a variable, right? Variables are things that you won't find on a wire. Signals are things that you will find on a wire.
Okay.
Okay.
So just giving it a name doesn't make it a variable. It just defines it within the program.
It just defines it within the program, right? So usually what happens, I think in the synthesis, is you can refer to a particular expression as a variable, but when the synthesis happens, when it actually generates the configuration of the hardware, it converts that expression into, or it moves that expression into whichever signal uses that particular variable. So it all of a sudden, the actual variable is not available, right? It's just merged in with whichever expression it's used to create a signal. I think there's some more stuff about that later on, so let's just see if we can find that. So one way to think about it is a signal is something that you can actually measure, and a variable is just a shorthand way of referring to an expression.
Got it.
Okay.
That makes sense.
Okay, so then we've got to think about the architecture, and the architecture is a little bit more complicated, right? We've got the name, and it has to implement a particular entity, the particular input-output relationships that we use, so you have to name which entity it's trying to implement. And then there's lots of potential optional items. You can define new types, you can define new signals, you can define new constants, you can define functions, procedures, or components, right? And then you need to end the architecture with a semicolon, right? And that's the sort of...
I had a question about the signals and constants. If you set a signal to like a set value of like 0, let's say, and never change it, would that also be considered a constant?
So a constant is just going to be a symbolic value, right? It's not actually going to be a measurable value on the wire. Whereas a signal it may have the effect of being a constant if you don't change it, but it is actually measurable even though you don't change it. Okay, one of them, the constant only exists while you're thinking about it, while you're doing the compilation, but as soon as it spits out into the actual device, the constant disappears, but the signal is still there. Okay? Does that answer the question? Yeah? Okay.
Yeah.
Here's a really simple example, right? We're either adding or anding variables together. And the key thing is this is the assignment operator. Right, assignment, there's two sorts of assignments. For signals, it's less than or equal. And for variables, it's colon equals. Okay. And we talked about strongly typed. We haven't used many libraries. There are lots of libraries around. The main library we've been using is some of the IEEE libraries. Okay? And particularly that allows us to use the std logic vector and some of the signed and unsigned arithmetic. Right, there's the some information about the IEEE, and they're I think we've used most of those, right? The basic one is the 1164, and then I think arith gives us some of the conversions, and then signed allows us to do signed arithmetic. Right, and this is where I don't think we actually, for this particular one, I don't think we actually need those two. I think the only thing we need is the 1164 to give us std logic. And there's another one, right? All of these should be, yeah, so this one's pulled out the other two because I don't think they're needed. Okay, and std logic is just a single vector, a single Boolean value, but usually we want buses or vectors or values with more than one bit. So there are different vector quantities. This is the standard way of doing it in VHDL, but we've mostly used std logic vector. Let's try that again. Std logic and then underscore vector, which is the IEEE type. And again, you just say std logic vector 7 down to 0 if you want to, if that's the order you want to do, or you can say 0 to 7 if you want ascending order. Right, and the most significant bit is always on the left of the range. So 7 down to 0, 0 down to 7, 7 in this case is the most significant bit, 0 in this case is the most significant bit. Right, and there's different sorts of signals. Internal signals really only exist inside the entity. External signals exist outside and allow you to connect it up to other devices. And there's some of the values that we've looked at. Maybe we haven't used some of them. We might have used integer. I don't think we used real. I don't think we used bit. I think we used logic instead of the bit value. Right. And I think I may have used Boolean in one example. And I'm not sure whether I used characters, but you can also play with text if you really want to in VHDL. Right. There's a string type if you need to do that. And you can deal with time. And we particularly dealt with time in when we're in the test vectors, sorry, in the test benches, right? We want to put some delays in our test bench, so we use the wait statement and, you know, wait 100 nanoseconds. Okay, funnily enough, with VHDL, you can do logic operations. Not, and, NAND, or, nor, XOR, XNOR. Right? All of those standard sorts of Boolean ops you want to do. But you can also do other things. Addition, subtraction, multiplication, division, modulus, remainder, absolute value, or exponentiation. Right? Raising something to a power. Right, and therewith there's a just a simple example of doing an addition. And you should remember that where we started with the labs is we started by building a 4-bit adder from discrete logic elements, the way we would think about it from building it with 74LS series devices on a breadboard. But then we found that there were issues with glitches, and in Lab 6 the aim is to replace that component-based approach for the 4-bit adder to just using something a bit, not quite this simple, but similar to this for the addition operation. And the nice thing about that is that addition operation removes the glitches that we saw in the component-based approach. So I'm actually kind of surprised about that one. Right? It means that it does it can figure out the difference between an assignment, which is what that less than or equal to is used for, also a Boolean expression comparing two values with the less than or equal to operation. And then I think we had some questions about what the difference between modulus and remainder is. And I think I went through that example. Okay. And there's also shift operations, shift left logical, shift left arithmetic, rotate left, and then the right versions of those as well. And you should remember the difference between a logical shift left, an arithmetic shift left, and a rotate left. And it's all about the sign bit. And the ampersand, this is one of the more confusing parts for me about when I see that ampersand operator, I always think of the AND operation. And for VHDL, it's not. It's about concatenation. So we can convert, we can run strings of bits together using the concatenation operator, the ampersand. And you will have seen that ampersand operation, operator in question 10 on the final. I think I talked about that briefly. Right, and there's assignment, which is just less than or equal to. And then we can model different delays. Instead of doing the assignment operation immediately, we can put in an after statement to say only do it after whatever the time is, 2 nanoseconds, 10 nanoseconds. Right, and there's two sorts. There's an inertial delay and a transport delay. An inertial delay it will remove small pulses. So if the pulse is less than, in this instance, 5 nanoseconds wide, it won't get assigned to the variable B. So if A bumps up for less than 5 nanoseconds, B won't see it. However, a transport delay will just delay B compared with A by the stated 5 nanoseconds. Okay, so they're the two different. One of them is about removing small pulses, and the other one is just about delaying. I don't know if you've done much programming, but I've done a bit, and one of my biggest beefs with the way sometimes I write code and certainly other people write code is when they use magic numbers. All right, you get 3 or 8 or some number that is just written directly into the code, and you've no idea what that 3 or 8 means. Is it a length? Is it a width? Is it a number of bits? What is it? So I really do like people in standard programming languages using appropriately named constants, so that if there is a constant value you need for a lot of places, that you use an appropriate name for it rather than just the number. It certainly makes it much easier if you need to move from an 8-bit wide bus to a 16-bit wide bus, rather than having to change all the values of 8 throughout the code. You can just change a single constant or generic statement, and all of a sudden they're all changed. You only have to change it in one place. Right? And generics and constants are similar, but they have a few differences. Generics are declared in the entity statement, right? So in the beginning part of a VHDL component, and that's the format there. Generic width colon integer is assigned to 7. So wherever you see the name width, now it'll be set to 7. Constants, on the other hand, are declared in the architecture. So if you like, a generic is part of the interface definition for the component, whereas a constant is a hidden part of the implementation. It's only required for the it's not required to be known by any part of the code that uses the device. So one of the really big things for me, and it took me a while to get my head around it last time I took this course, is every statement in VHDL outside of a process statement is happening at exactly the same time, right? So just because you've got statements in a particular order doesn't matter. They're all happening at once. It's like you've got a massively parallel machine. All of those statements happen at the same time. It's only once you encapsulate things inside a process statement that you get sequential operation, right? So one way to think about that is if you've got assignment statements out process, they're not really assignments, they're more like wiring, right? As soon as you do that assignment, that thing on the right-hand side is connected straight to the thing on the left-hand side, always. And it's something that was a bit eye-opening for me, right? So here is an example, and here there's nothing getting in the way of the connections for node 1 and for X. As soon as A changes, node 1 will change. As soon as C changes, X will change. There may be a little bit of a propagation delay between B changing and X changing, just because there's a gate, an XOR in there before node 1 gets calculated, but it's happening pretty much immediately.
This might be a silly question since we're like almost done with the semester, but difference, like, doesn't matter where the arrow points. Like, obviously A, X, or B resides in node 1, but could you write it as like the A, X, or B on the other side with the arrow pointing to the node 1 to the right? Like, if you swapped it, would it be still the same thing?
No, it's not the same thing. I mean, you could think about that maybe, but no, that I don't believe that is an assignment operator in VHDL. I think it's just I'm not sure it's anything in VHDL. Okay, I mean, you could think about it, but I don't think that's defined in VH. Okay, Quentin. Yeah.
Okay. I might be wrong, but I thought like in the test bench it points the other way. But I might be wrong,
yeah,
though.
you're right. You're right. It is, but it's only in the map statement, right? I think there's a map, and then it goes A to A, right? Let's see if we can find that. I don't know whether I've got a test bench. And I'm running a little longer than I thought. That's okay. Let's see. I don't know whether this one's got a that's that. It does have a simulation. Right, you're right. So I think it's only when you're doing a mapping. I think it's only valid in this case. Let's right. I don't think that's a valid thing, but let's just see what happens. I really do need to get a faster Windows machine. Thinking about it. Yeah, there we go. Yeah, I don't think that's a valid statement. Okay in a map statement, but I don't think it's a valid assignment statement outside of that. Okay.
One of those things like never really questioned, but
Yeah, no,
just,
worthwhile asking, right? It is yeah. I think it's only valid in the map statement. Okay. Then there's a conditional assignments, and again you can do these in concurrent statements outside of a process, and they're kind of cool. So you can have a 1 or a 0 based on some condition, and that kind of works nicely. Or you can use the when statement, right? Well, that is the when statement. When else? And when else? And again, this is like a one-line implementation of a multiplexer, right? Either you present A if the select is 0. If the select line is not 0, then you present B, which is kind of cool. And right, there's a more complicated with statement, right? It's like what in another programming language might be a switch statement, right? And the nice thing about the with statement is you can effectively just write down the truth table of a complicated Boolean expression without having to do any Boolean logic, right? You don't have to decompose it into what's the simplified Boolean expression for what each of these bits is doing in order to get this output. And that can be useful. And I want to see. Did want to quickly run through. There's components. We talked pretty much. I did want to quickly run through process statements. And that's port maps. And that's where that's where you see that version of the assignment. I did want to see about, where do we get to? Process, right? So sometimes you actually do want to calculate things in a sequential way. And a process statement is one way to do that. The process statement can be named, and you can tell the process statement to execute always if you don't have a sensitivity list following it. Or if you use a sensitivity list, you can say execute this process every time one of these signals changes. Right? And the usual things that you want to run a process on are the clock, or a button pressed, or maybe a reset, or some other things. And that's the general form of what it does. And these statements 1, 2, and 3 happen in sequence. One thing you need to remember about process statements is if anything changes, if any signal changes value through the process, it doesn't actually change until after the process finishes. So signal values only change upon exit. Right, and I think some of you had some issues with one of the labs where you were doing some of the wiring inside the process statement, and then there was an issue with the output only showing up a clock cycle after you thought it should have been showing up, and that was because those wirings, the connections, were being done inside the process statement. Because they were done inside the process statement, the change to the values of the signals wasn't implemented until after the process exited, and the process only exited at the end, right? So you didn't get, it looked like there was a delay. As soon as you took those assignment statements, those wirings outside of the process, which is where they should have been, everything started working correct. Yeah, and there's a simple example. This executes every time there's a change in the clock. So when there's a negative or a positive going transition of the clock, this Q value gets set to the D input. Okay, we talked about weights. The only other thing I really want to remind you about is test benches, which I think are down the bottom here. There we go, test benches. So remember, the whole point of this is, or part of the point of this course is to remind you that having a process to do this, right? You do the design, you do the test, and you do the deploy. Sometimes you can't do the test until after you've done the deploy, but for the vast majority of things, you can do the test before you do the deploy. Sometimes the deploy is very expensive. Thankfully for the boards we've got, it's not that expensive, but sometimes the deployment is expensive and you want to make sure everything's going to work, so you need to put together a test bench. And we had a look at right, this test bench was auto-generated back on the 21st, and about the only thing I've added to this test bench is this piece in the always, right? It's a loop, and it just goes through and applies possible values of A in and B in to those inputs, and a different value to the subtract input. This is for lab 6 for generating the glitches to show in lab 6. Okay. I don't have, oh, the only piece about this is where possible, you should use assert statements, because this example doesn't use any assert, so it's not actually automatically testing anything. You have to eyeball the result of the simulation. If you can set it up so that it uses asserts and reports errors, then you've got an automated test. And then you can have that test run without human intervention, so that if you make changes, you just push those changes to your test system, and your test system can do the simulation by itself. And if the test system doesn't tell you there's any errors, you're good to go, right? But if the test system says there are errors, then maybe a change you made broke something. And that's the nice thing about having automated tests. Okay, I don't have much else to talk about. I've pretty much done what I wanted to do for CET466. I've talked about what's on the final. Most of you have already booked your sessions. Thank you for that. Please give me feedback on the course evaluation. I know Blackboard's going to annoy you about it for the next little while. I put the link into I think it was the reminders section. I don't see the results survey until January 6th, so please have a look at doing that. I think 3 of 27 people. I think the university likes at least half of the students to put stuff in. At least that's when I think that's when the circle goes green. Right at the moment, see if I can move that over. Maybe. Doesn't want to move over. There we go. So at the moment, is saying 3 of 27. It's yellow. I think once it gets over 50%, it goes green. Okay. If there are no other questions, or if you want to do labs, to ask questions about labs or anything, just note I won't be answering any about the final unless it's now on video, or if there is a question and I think it needs an answer, if I get it via email or what have you, I won't give it to you personally. I will make a video or a posting in Blackboard about it, because I don't want to give different students different information. I want everybody to have the same information available. Okay, thank you very much for a completely online semester. I forgot. I knew there was something. I need to get your boards back, right? There's no rush. If I could get them back sometime before December 31st, that would be good. Please, once you've finished the labs, let me know and we can organise to meet up either somewhere on CCSU campus or at some other mutually accessible place. Okay? So if there's nothing else, let's just leave it there. Thank you very much.
Professor, have a nice day.
Yeah, you too.
I had one question about the game.
Yep.
When we submit, actually, is that Is today the last day, or do we have to till
You've
the 12th?
you've got until whenever. That's okay. I'm not a big fan of. Well, the only reason I'm a fan of deadlines is I tried not setting deadlines, and at the end of semester, I had about 300 things to mark, and I don't want to. I don't want to do that again, right? So, I set deadlines throughout the semester so that I have a reasonable marking load throughout the semester. So there's no. Let me just check that I haven't set a close date on the assignment, but yeah, there's.
So, are we taking like a screenshot of like the completed game
Yeah,
with
so
a review attached in the comment of the
yeah,
submission?
let me show you. I've forgotten who finished it. But let me show you what. Let me just check that it's not going to close out. No, it's not going to close out. I think it's currently saying due on the 12th, but it's not going to close on you, so you can submit after the 12th. I will sometime after the 12th. I will start closing things down, but I'll send out an announcement about.
And the review. What does that consist of again? Just like what our thoughts, our final thoughts of the game or something?
Yeah, that would be good. Let me just show you the submission I got, wherever it got to. Yeah, so it looks like a personal achievements section on the game, and it'll tell you, it'll say there. Let me just open up screenshots. Right, so this is right. There's various pieces, and right at the bottom there it says, "Look at me! I built a CPU," and it was unlocked on December 2nd at 8:24 p.m. Okay, and that's what I'm looking for. And 7.7 hours. Okay, that's good to know too. Very good. Okay, does that answer the question?
Yep. Thank you.
Okay. Any other questions?
No, I believe that's it. Thank you very much.
No worries.
I will talk to you on the 12th. Final.
Yeah. Yep. Talk to you then, Quentin. Bye-bye.
Bye.
Okay. Way. Let's leave it there. I'll shut down the